Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Start with the name of Allah Almighty, who is the most beneficial and merciful. First of all, I want to say Assalamu alaikum to everyone. I hope that all of you will be fine. All of you are going very well in your life. So, dear friends, today we will discuss about the other three questions of the calculus with analytical geometry exercise set 1.1. In the first video, we have already discussed first three questions of the exercise 1.1, and in this video we will discuss about the other three questions of the exercise 1.1. So first of all, we are going to reading the statement of the question number 4. The fourth question statement is that express x is greater than 3 and less than 7 in a modulus notation. Express x is greater than 3, less than 7 in modulo notation. Now we are going to solve the question number 4. So as we know that the absolute value of x minus a is less than b. This thing we know already. Absolute value of x minus a is less than 3. When we open this equation, then we get two values of b. One is a negative value of b and the second is a positive value of b. So when we open the notation of absolute value of x minus a less than b, then we get the equation. So there are two types of the values. One is a negative and the second is a positive value. So we can write as x minus a is greater than minus b and less than here. So in this equation is x minus a is greater than minus b and less than b. Adding a on both sides. When we add the a on both sides, then we get a minus b less than x minus a, which is also less than a plus b. This is the first equation. So the given equation is that x is greater than 3 and less than 7. When we compare these both equations, then we get a minus b, which is equal to 3, and a plus b, which is equal to 7. These sides are equal and these sides are equal. So when we compare these sides, then we get a minus b, which is equal to 3. And when we compare these sides, a plus b, which is equal to 7. So there are two types of the further equation. In this side, first of all, we add these both equations and get the value of a, and at a second we subtract these both equations, we get the value of b. Now we are going to adding these both equations. So first equation is a minus b, which is equal to 3, and the second equation is a plus b, which is equal to 7. When we add these both equations, then b is cancelled with b. It is because these contain opposite side, and when we add a plus a, then we get a 2a. When we add 7 and 3, we get the answer 10. Here 2 is multiplying with a, and when we transfer the 2 into another side, it will be dividing by 10. So 2 1s are 2 and 2 5s are 10. So the value of the a will be 5. And in this side, we are subtracting both these equations to get the value of b. So when we subtracting, the first equation can be written as it is, and the sign of the second equation is changed. So when we subtract this equation, then a is cancelled with a, and minus b, answer will be minus 2b. So 3 minus 7, answer will be minus 4. Here minus 2 is multiplying with b, and when we transfer it to the other side, then it is dividing by minus 4. So minus is cancelled with minus, and 2 ones are 2 and 2 twos are 4. So the value of the B is 2. Now we are going to discuss the statement of the question number 5th. In a 5th question, let sigma is greater than 0 and A belongs to R. Show that A minus sigma less than X less than A plus sigma if and only if absolute value of X minus A less than sigma. So this thing is a given, that this is a given thing. When we open this notation, then we get the two values. One value is a negative and the second is a positive value. So in this equation, at the mid of the equation X minus A, when we transfer this minus A in this side and in this side, then the sign of the A will be changed. So when we transfer the A to the both sides, the equation becomes A minus sigma less than X A minus sigma less than X less than sigma plus A. Subtracting A on a both side. Subtracting A on a both side. When we subtract the A on a both side, then we get final equation minus sigma less than X minus A, and which is less than sigma. So we can write these equations as by the definition, absolute value of X minus A less than sigma. Now we are going to discussing the 6th question of the calculus with analytical geometry. So the statement of the 6th question is that give an example of a set of the rational numbers which is bounded above but does not have a rational supremum. So the solution of the 6th question is that we know that A is a set of the rational numbers. This is a set of the rational numbers which contain a irrational value. It is because when we take a square root on this equation, then this equation answer will be 2 square root. So 2 square root is a irrational number. So it means that this set does not contain any supremum and any rational number, but the all number of this set are rational, irrational numbers. So you can write this set, and you can write that this set does not have supreme. This set does not have supremum values.